Okay. Okay. Till now we have discussed the so many instructions. Okay. Today also we'll discuss the two more instructions. Okay. Till today we have discussed about the programming status. Sorry, data processing instructions. Okay. Data processing instructions. In that data processing instructions only we have discussed the move instructions. Okay. Then the arithmetic instructions and logical instructions, and also we seen the compare instructions, and also we have seen the multiply instructions. Yes sir, multiply instructions. And even we have discussed the branch instructions. Okay, in that we have seen the blx, yeah, bx, blx. Okay, and also we will discuss the load store instructions. Load store load store instructions. Okay, in the load store instruction only we are discussed about the single register instruction, multiple register instruction, and also we have seen the in the multiple instructions itself we seen the what that stack operation, stack operation or stack instructions, and also we have seen the swap instructions also. Yes sir, swap instructions also. Today we'll discuss the uh, software interrupt instructions, and also we'll see the program status register. Program status register instructions also. And also in this we'll discuss the in the software interrupt instructions only we'll discuss the one more is that is the constant instructions, and also we'll see the condition instructions also. Okay, today we'll discuss these many two more four more concepts. This will covers completes the your second module. Okay, second module. Okay, I hope I taught you in detail about the this instruction set, because we need this instruction set for the next two models. Okay, there you would not face any problems. Okay, you should have to come to know if I use the any one instructions in there while writing the program, there should have to you should have come to know what is that type of instruction, what's the use of that instruction, and also why I'm writing, what is the flow of that instruction, what's performing the operation. You should have to know that one. Okay, at least you should not face any problem there. Okay, there in the third module you will lead the what only the C programming concepts, basic concepts. Okay, complete C program I don't need. At least you should have the some common idea, some basic concepts of the C programming, and thereafter you need these many instruction set also there while writing the program. Okay, that's what I'm teaching these instruction set in detail only. Okay, today we'll complete the second module. Okay, we'll create while studying the software interrupt instructions, and also we'll study the program status register instructions also. Okay, first one we'll consider the software interrupt instructions. Okay, software interrupt instruction. Okay, what is the interrupt? Okay, what is the interrupt? You should have to know. Okay, software. Okay, this instruction. Okay, what is this interrupt? It's a interrupt is an in the digital computer. In the digital computer, interrupt is an input to the this input signals to the processor. Okay, it's input signals to the processor. It will perform. It will ask to the processor to service. Okay, service immediately. Okay, it has the higher priority. That's what this interrupt has to be. This is an input signal. It's an input signal to where into the input signal to the signal to the processor. Okay, processor to perform what is it has the higher priority to give the to have the higher priority to service it. Okay, to service it we call as the interrupts. Okay, interrupt may be software interrupt may be causes the some exceptions because of the requesting to the processor. Okay, sometimes interrupts are called as the exception also. Okay, if you are okay, for example, if you are running a main program here, it's a one of the biggest program. Okay, there you will be writing the so many concepts here. Okay, so many, this is big of program. The program which is the repeatedly which will be used, okay, that is to be written where in the, okay, that's nothing but the we'll be writing the subroutine program. We'll be writing in the subroutine program. Okay, that's what we call the interrupt subroutine program. Okay, instruction interrupt subroutine program. This subroutine program will be written in the because of the which will be used. Okay, which will be used frequently. Which will be used frequently. Which will be used frequently. That is to be written in the subroutine program. That is to be called every time wherever it is necessary in the main program. That is to be called with the help of the some address. Okay, that one we skip there. This is the main program. This is the main program. It will be running like this, like this. If any interrupt occurs like this at this stage, that interrupt will be goes to the where in the subroutine program. Okay, this will be given here the LR. That's nothing but the link registers. Okay, which will give the some link registers. Okay, this LR will becomes now here. LR will becomes here the PC. That's nothing but the program counter address here. LR will be holding the address of this subroutine program. Now LR will becomes the PC. Okay, next PC. Okay, this program whatever the running that we call as the main program. It will be holding the some logic here. At the return, okay, it has to be returned to where in the main program. It is to be done with the return program consists of the LR again. LR will be equivalent to the PC of the next instruction which will be going to be executed. Okay, that's what we call as the LR. Okay, LR and the PC. Okay, that's nothing but here the we are exception. We are interrupting to the main program to in order to service the some subroutine programs. Okay, that we call as the interrupts. Okay, that we call the interrupts. These interrupts are are raised. Okay, will be with the help of the software interrupt instructions. Software interrupt instructions. Okay, software interrupt instructions will have the only two. It will be consist of the only the address. Okay, this will be consist of the only soft interrupt address here. Each and every interrupts have its own addresses here. Okay, if I am using the software interrupt address, then it will be having the some addresses. If I am using the undefined interrupt, okay, if I am using the some other type of interrupts or the reset interrupt is there, and also if I am using the some interrupt request interrupt is there, and fast interrupt request. Each and every instruction, these interrupts will have the separate addresses, separate addresses. Okay, those addresses will be written here. Okay, first we'll be writing the software interrupt, then will be address of that particular address of this instruction. Okay, if you are sending the 1 2 3 4 5 6 some data here, okay, some data that is to be written with the some address here. Which address will be given here? That is to be some particular. Okay, here I am using the software. Okay, if I am using the abort is the one of the interrupt. This is also having the mode which will be going to be okay data abort. Okay, this is the data abort instruction. Interrupt is there. This will go to the mode which mode? Abort mode. Okay, abort mode. This we call the abort mode. Okay, it is having the some address here. Okay, this is having the some address here. Each and every interrupts, okay, it will be written is stored in the one address in the memory location. Whenever we call the separate interrupts, ಇನ್ನು ಯಾವುದೇ ಒಂದು interrupt ಬಂತಂತಿಟ್ವ ಅದು ಯಾವ ಟೈಪ್ interrupt ಅದ ಅಂತ ಪ್ರೊಸೆಸರ್ ಗೊತ್ತಾಗಲ್ಲ. So that will give the some addresses of particular of the interrupt. These interrupts are stored in the some memory locations. Those memory locations are given in the separate. Okay, first if I use the reset interrupt in that will go to the supervisor mode. SVC is nothing but super reset interrupt occur agidre is supervisor mode al hogutta, so that it will be having the addresses as the 0x 000 4 zeros also. Okay, 4 zeros, and also we have the seen the abort undefined also will have the separate. Okay, undefined interrupt will be having the UND. Okay, and mode, this is the mode, this is the name of the interrupt, this is the addresses. Okay, this is the address, okay. If I am using the undefined address, that will go to the undefined mode. Then this is address for the 0x 4 zeros 3 zeros and 4 at least. Okay, Always you should have to remember the, always it is to be incremented with how much? 4. Okay, next if I am using the software interrupt instruction, SWI, this will move to the, if I am using the software interrupt instruction, okay, software interrupt mode, then it will move, this processor will move to the where in the mode of the SVC. SVC is nothing but the supervisor mode. ಈಗ ನಾನು ಒಂದೊಂದು ಇಂಟ್ರಪ್ಟ್ ರನ್ ಮಾಡ್ತಿದ್ರೆ, ಯಾವ್ದಾದ್ರು ಒಂದು ಇಂಟ್ರಪ್ಟ್ ರನ್ ಮಾಡ್ತಿದ್ರೆ, ಪ್ರೊಸೆಸರ್ ವಿಲ್ ಮೂವ್ ರನ್ ಇನ್ ದ ಸಪ್ರೇಟ್ ಮೋಡ್. Okay, if I am running the software interrupt interrupt, then that definitely for the software interrupt mode, then the instruction for this, it will move to the processor will move to the in the mode of what? Supervisor mode. Then this is the address for this one is the 0x 4 zeros 3 zeros. It is to be doubled here. 4 plus 4 how much? 8. Now next if I am moving the free fetch abort, free fetch abort, then it will be having the, it will be moving the abort mode. Okay, it is moving the, my processor will be running in the abort mode. Okay, then the address for this prefetch abort mode, then 0x 4 zeros 3 zeros, this is the C. C is nothing but how much? 12. Okay, 12. C is nothing but 12. A is 10, B is 11, C is 12. Okay, like this we have the separate, even data abort is there. Okay, data abort, that's also one of the, this is also one of the interrupt. Okay, this will be if is my processor is in the running the data abort interrupt, then the processor will move to the abort mode. Then the address for particular abort instruction in the memory is the 0x 4 zeros with the 00. This is how much it will become? C. Now it will become so much, it's 10. It becomes what? 10. 10 is nothing but 16. 12 is nothing but a C. 16 is nothing but 16 ones are 16. Okay, how much is left? 0, no? 0. 10 is nothing but the 16 itself. Okay, it's a increment every time 4, 4, 4. Like this we have the reverse reserved. Okay, sorry. Reserved interrupt is there. Okay, in the CPSR we'll have the not applicable, any will not go there, and also we have the, this address will be particularly 0x 00. This will be what here, the 0014 because it's to be added to the 4 here once again. Okay, reserved. Next is what here, the IRQ, and also we have the FIQ. Okay, IRQ is nothing but the interrupt request, FIQ is nothing but the fast interrupt request. Okay, this is also will moving in the interrupt. Okay, interrupt mode IRQ, this is also moving in the IRQ. Interrupt mode is there. Yes, interrupt mode is there. For this particular address is that 0x 4 zeros, this would be what here, the 14, it will becomes 18. This will becomes 18. How it 18 it becomes 4 and 4 is nothing but how much here, the, it's 16, it's 20, it's 24. How 24? 16 ones are, okay. How much we left here? 2, it's around 1. How much we left it here? 8. It's what we are, the 0. It's the 18. 18 is the right answer. Okay, right answer. FIQ 0x 0040 00. We have the 1C. It's nothing but the, it becomes what here, the 24, 28, 32, 28. It becomes 16 ones are. Where we left with how much here? 2. It's the 1. What 12 is nothing but the C. 1C is the addressing mode for this one. Okay, each and every interrupt has its own address modes. Okay, addresses. Those addresses are given in the separate here. What type of interrupt I am using here? Software interrupt. Okay, software interrupt instruction will be given with the SWI. It should be holding the some value here. Okay, that has to be copied. Okay, will be this software interrupt instruction will hold the some address here. This address here will be given the 0x 0040 with 008 only. Yes, sir. 8 only. We have to move. Okay, we should have to write before the SWI. Okay. This is all about the interrupt software interrupt instruction. We have the instruction for this one. Yeah, okay. We have the syntax. Okay. What how to write the syntax means what instruction format here. How it would be here the SWI. Okay. Condition is the will be condition field will be available in each and every instruction. Okay. This I will discuss at the end of the class. Okay. And also we have the SWI number. SWI number. Okay, just to copy these many things I will be telling you. Okay, take the heading as the software interrupt instruction. Take the heading as the software interrupt instruction. Software interrupt instruction. In digital computers, 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 an interrupt is an interrupt is an interrupt is an input signal. An interrupt is an input signal to the processor to the processor to the processor indicating an indicating an indicating an event indicating an event that needs immediate attention that needs immediate attention that needs immediate attention. Okay, just to copy this figure. Okay, just to write the main program, thereafter you have to write the subroutine program here. Okay. Okay, just to copy this figure. Main program, subroutine program. ISR is the interrupt service routine. Interrupt service routine program. ISR is nothing but the interrupt service routine. This is the subroutine program. They have written here. Okay. If any interrupt occurs for this instruction after the execution of this instruction, then the particular main program stops here only. That will move to the subroutine program. Thereafter, it will get the some addresses. Thereafter, it acts as what interrupt LR becomes PC program counter. Then it will start executing the particular program. After that, return the after that execution, return address will be there. This return address is nothing but the LC. This LC will becomes what now the PC to the main program. Okay, PC to the main program here. Okay. Next, copy the okay. Just next is write the syntax here. Write the syntax here. Write the syntax software. Okay, SWI. Write the SWI condition, SWI number. Okay, this is the flower bracket. I am writing here SWI. Okay, condition SWI number. Okay, SWI number. Okay, then take this table here. Then write the table this one. Okay, we have the you should have to write in the examination. Okay, this is the very important. They will ask for the 5 marks. This is very easiest topic. Okay. Okay, this is the name of the interrupt and the mode and this is the address to the particular mode. Address to the particular mode. Okay, this is the reset. Okay, this is what the reset. Okay, reset instruction interrupt occurs, then this processor definitely move to the where into the supervisor mode. Okay, how many modes are there? 7 modes are there. One is called the user mode, system mode, supervisor mode, abort mode, interrupt request mode, fast interrupt request mode, supervisor mode. Like this, we have the around 7 modes are there. If my processor is working, then definitely my processor will be switching from the one mode to another mode for running the processor, okay, working the system here. The for that will if any interrupt occurs, particular reset, okay, reset interrupt occurs, then it will move the processor will move to the supervisor mode, and the address to the particular reset okay, reset interrupt we have stored in the memory as the four zeros, next four zeros, 0x with the four zeros, then the undefined interrupt occurs, then it should be moved to where in the undefined mode, and definitely this is the address for this undefined interrupt that is be incremented with 4. Next software interrupt interrupt occurs, software interrupt occurs, then definitely my software interrupt for this one my processor will move to the where working with the supervisor mode, okay. Then definitely for this interrupt we have the address for particular 0x4030 4 zeros 308, okay. Next is what free fetch abort mode. This will be for this free fetch abort interrupt will then the processor will be walk in the where in the abort mode only. We'll have this one address this 0x4030C. Okay, definitely next is interrupt is what here the data abort. Okay, data abort interrupt. For this we have the move to the where in the abort mode, but we have to move the 0x40 for the reserved interrupt we have the it is not applicable any mode here. This is a 0x400014, okay. This is the address for this one, okay. Next interrupt request is there, this will be interrupt request interrupt, then the my processor will move to the where it which mode interrupt request mode only. There we will have the address for this one, we have the 0x40 that should be 400018. Then the fast interrupt request mode is the one which will move to the with the interrupt mode only, interrupt request mode, that the address to the particular interrupt mode we have the 0x400001C, okay. Just to write it. Copy that one. You always remember this one, okay. Whenever the my software interrupt instruction executes, definitely the processor will move, okay. Processor will be moving to the supervisor mode only. You have to write in the words, okay. What I am explaining, that one you should have to write in the words. Then the my offset will be incremented with how much 8, okay. You should have to mention as the 0x8 also, at least 0x8 only, or else 0x, okay, 40308 only you should have to mention there, okay, while explaining, okay. Okay, next we'll consider the one example, okay. This is all about the software interrupt instruction. What is the interrupt is? It's an input signals to the processor which is requesting to the processor to give the higher priority or give the attention to this one. We call it the interrupt. Software interrupt instruction is the one of the interrupt which will be having the move to the supervisor mode. Whenever the software interrupt instruction executes, then my processor will definitely move to the where in the supervisor mode will have the offset with 8, offset with 8 about the definition. Then you have to write this figure, then you have to write the syntax about this syntax, okay. Thereafter you have to write this table, okay. About this table you can write your own words, and later you should have to give the one example for this instruction, one example for this instruction, okay. We'll write the one example for this one, we'll see the one example for this one. Okay. For example, precondition, it's nothing but the before execution of the software interrupt instructions, we have the CPSR status as the CPSR status as what here the NZ CV Q I Q, okay, Q I F T, okay, IFT. Next is what here the user. Next is the user, okay. I have not written anything here, okay. I have not written any capital letter. If I written the any capital letter, definitely that CPSR will be holding the flag of that particular interrupt, okay. There's nothing but the here the flag V. I am raising the flag V. Overflow flag will be carried out here. Overflow carry, okay. Overflow will be overflow. This is the N is the negative, this is the zero flag, this is carry flag, this is overflow, this is the saturation flag, I is the interrupt flag, F is the fast interrupt flag, T is what here the thumb. Okay, if it is the T equals to what here the capital T, definitely my processor will executing what here the thumb instructions. If the T is not a equals to T only, that's not in the thumb mode, then the definitely my processor is executing what kind of instructions? ARM7 instructions only. ARM7 instructions. That's the ARM7 instructions. Okay. If the T equals to 0, T equals to, if the T equals to 1, T equals to 0. T equals to 1 idag enaಗ್ತದ, that is my processor is running the thumb instructions, 16-bit thumb instructions. If the T equals to 0, T equals to small letter, T equals to 0, then my processor is running the, is not running the thumb instructions. It's running the ARM instructions only. ARM 16-bit, ARM 32-bit of instructions only. Okay. 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 Let me write the full complete example. Next is what here the PC equals to 0 0 0x. You should have to write the some address here. Address is always start with the 0x. Why 0x? It's in the hexadecimal. If I start with the 0b, it's in the byte mode. Okay. If I am starting the 0x is nothing but the what here the hexadecimal value. That's what I need. What 8 4 is how much? 32. 8 4 is 32. That's what I will be writing the 4 zeros means what here? It becomes a 12 or 16. 16 over. Okay, I need to write one more 12. Okay, 8 3 zeros means here the I am using this program counter address here. Okay, thereafter I will be writing the link registers. LR will be link registers. Okay, program counter will be running, the main program will be running here. That is becomes the program counter. Program counter is nothing but the register which will be holding the next instruction which will be going to be executed. Okay, then if it's any program, okay, if any interrupt occurs, then the program counter will becomes now the LR link registers. Okay, this LR, okay, the LR is nothing but the subroutine program. Okay, subroutine program. Thus program counter once again it is running. Okay, then the return instruction is there. That return instruction will consist of the link registers. Okay, this link of the next instruction which will be going to be executed in the main program. Okay, that's nothing but here the LR I am giving link register address here the that's the 0x 003F. Okay, and also 4Fs. Okay, 4Fs. Okay, 4Fs. F is nothing but how much? 15. Asa 15 now. Okay, R naught equals to what here the 0x12. X12 is how much? What is the x12? 12 is which one? C is for the 12. C is for the 12. Huh? 8 is for what? Supervisor mode. Okay, supervisor mode. Okay, I have given that one. No? 12 is for what? 10. Okay, 10. 12 is nothing but the C only. That's in the prefetch abort mode. Okay, let me write whether it's a prefetch abort mode or not. Okay. Okay, then I am running the one program, that's the one instruction that we call the SWI. SWI is nothing the software interrupt instruction which will be holding the some value here. Okay, not a address here 0x 1 2 3 4 5 6 7 8. Okay, this is can be addressor thing. And this is the main address. Okay, if I am using the software interrupt instruction will hold the value address as the 0x 40 308. Okay, you have seen in the vector table of the interrupts. Okay, that's we call the referred as the vector table. There a vector table consists of the 0x 408 in that one. This we call the address of this particular software interrupt instruction. Okay, after execution this instruction, then the my conditions of the post instruction, post of the CPSR will becomes what here the SPSR will becomes what the CPSR. Okay, SPSR will becomes what the CPSR. NZ CVQIFT user. Okay, user. But here I am using what the sending executing the software interrupt instruction. Thereafter the my processor has to move to some user mode to where in the SVC mode. SVC mode is nothing but the ಸೂಪರ್ವೈಸರ್ ಮೋಡ್. ಯಾವುದೋ ಒಂದು ಯೂಸರ್ ಮೋಡ್ ಯಾವುದೋ ಒಂದು ಮೋಡ್ನಿಂದ ಇದು ಎಕ್ಸಿಕ್ಯೂಟ್ ಆಗ್ತಿದ್ರೆ ಅದು ದಟ್ ಇಸ್ ಟು ಬಿ ಸ್ವಿಚ್ ಟು ವೇರ್ ಇಂದ ಸೂಪರ್ವೈಸರ್ ಮೋಡಲ್ಲಿ ಎಕ್ಸಿಕ್ಯೂಟ್ ಆಗಬೇಕು. ಸೂಪರ್ವೈಸರ್ ಮೋಡ್ ದೆನ್ ದ ಡೆಫಿನೆಟ್ಲಿ ದ this address for this one CPSR will becomes what here the NZCVQI caps FT. Okay, the I becomes caps means what here the interrupt mode is running here. Interrupt mode is running, so that then the CPSR, then the PC will becomes what here the PC will be holding the earlier it was how much here the 8,000. Now it will becomes what there the then the now it will becomes what here the address of this one. Okay, this link register will becomes what PC now. As I told you now, PC becomes LR becomes PC. Now the LR, this is the what we LR link registers. Okay, address here. That's what PC will becomes the LR. LR is nothing but the how much 0x 40308. Okay, now the LR will be after the execution of that instruction. Subroutine program software interrupt instruction, that will be moved to how much, that will be incremented by 4. That will be incremented by 4. That's for the user mode. Okay, this is the PC is now incremented with how much, LR will be holding the incremented of the PC 0x 408 now. Okay, 4 now. Okay, now R0 will be as it is. R0 will be 0x12 only. 0x12 only. Copy this one. This is the main example. They will ask in the examination also. Then you will be write the explanation for this example. LR becomes a PC. PC becomes LR. Okay, you should have to remember. ಇದು ಎಲ್ಲರೂ ಹೋಗ್ಬಿಡ್ತದ, ಇದು ಎಲ್ಲರೂ ಹೋಗಿ ಅದು ಪಿ ಸಿ ರನ್ಸ್ ವಾಟ್ ಇಸ್ subroutine program. Then the return address would be what here, something which will be multiply with what, sorry, added with the 4. We are adding with 4 means it is the 8,000. Now it becomes the 8,004. PC becomes LR. LR ಗೆ ಮತ್ತೆ 4 add ಮಾಡಿದಾಗ that will becomes what now, PC will be this LR will becomes PC. That PC holding that address is added with 4. That becomes the LR here. I hope you all following this one. Just to use your common sense. Okay, definitely will come to know what is the software interrupt instruction. This is the only one example we have the software interrupt instructions. Then we'll move to the next topic that we call the data processing instructions. Sorry, program status register instructions.